All right, so now we are moving on to confidence intervals for the means. So this should be very similar to what we have already done. We're just talking about it for the mean now. So remember, if we are having a confidence interval, right, we need to look at the statistic. So a statistic, right, the sample mean is going to be X bar, right? So we got to look at that statistic. And what we do is we take the statistic, subtract a little bit, add a little bit. And that is what our population mean should be between, right? Take your sample mean, subtract a little bit, add a little bit. And that's going to be our interval. The other way, of course, you could do it, write an interval notation like that. Also works. All right, so let's just do a quick review. Again, this is going to be very similar to what we've already talked about. So for a given confidence interval, just one this time and no sample size, find the sample mean and the margin of error. So if this is our confidence interval, right, the low number, we know this low number is going to be X bar minus E. The big number is going to be X bar plus E. So, right, if we know that the low number is 5.213 and the high number is 9.109, right? Then X bar should be right slap dab in the middle, right? So how do you find the number in the middle? You just add them together and divide by 2. Find the average, find the mean. So we know that X bar is going to be the low plus the high, divide by 2, which we can see is 7.161. So that's our X bar. Now I just need to find the margin of error. Well, remember the low is X bar minus E. The high is X bar plus E. And since we have X bar right dab in the middle, and it's 7.161, we can see that this should be E, right? You had to subtract E to get to the low number. You had to add E to get to the big number. So we can just do X bar minus the low number to get our E, right? So 7.161 minus 5.213, and we should get that E is 1.948. And we're done. All right. So requirements for confidence intervals for a mean, estimating a mean. This is way simpler than the last one. And it comes down to just 2 things that we've already talked about. Number 1, population either needs to be normally distributed, or sample size has to be what? Greater than or equal to 30. Yeah, same rules for the central limit theorem. Cool. So let's do some problems. So problem number 1 on your work sheet for the word problems. In a test of weight loss programs, 40 adults used the Atkins weight loss program. After 12 months, their mean weight loss was found to be 2.1 pounds with a standard deviation of 4.8. So construct a confidence interval. So when it comes to the mean, what we are going to use for confidence intervals is t-interval. We will be using t-interval. So again, it's going to be in second vars under that distribution. No, sorry, I lied. It'll be stat going over to test, right? It'll be about number 7, it should be. So make sure it's t-interval, not t-test. We're not doing t-test, we're doing t-interval. So about number 7. All right. So when we do, so first, let's make sure that our requirements work for it. So are our requirements met? So is the population normal? We don't know. It doesn't tell us. However, let's look about the sample size. The sample size is 40, which is definitely bigger than 30. So we're fine. We can definitely do this. All right. So going to our t-interval, We know that our input is going to be stats because they gave us statistics, right? They gave us a sample mean, a sample standard deviation. So x bar is going to be 2.1, right? That's our sample mean. Sx is 4.8. That's our standard deviation. N is 40. And C level is 0.90, right? That's what it gave us, confidence level. So when we type all this into our calculator, we should see it'll say 0.8 and 3.4. So here is our confidence interval. Now we want to find the margin of error. So again, right, just like in example number 1, all we need to do is take our x bar, take our statistic, and subtract the low number. So 2.1 minus 0.8, and we see that E is 1.3. Or, yeah, 1.3. Good. So number 1, does the Atkins program appear to be effective? Does it appear to be effective? So if you're on a weight loss program, if it's effective, how many pounds should you be losing more than? If it's effective, if it works, you're going to be losing more than 0 pounds, right? If it's just effective, we're not saying people are going to want it. We're not saying anything that. We're just saying, does it work? Does all this research actually work? So if you look at our confidence interval, we said it was 0.8 and 3.4. And we see that 0 is on the left side, right? So if we had a number line, right, 0 would be way over there. So any number between here, right? Remember we said that you could be 1, it could be 3.2, it could be 2.0, it could be 2.1, 2.12, whatever, right? But we do see that every single number between these two is bigger than 0, right? So, is it effective? Will you lose weight? Absolutely, yeah. So, we can say, so is it effective? Yes, because the entire confidence interval is above 0. Now, is it practical? Is anybody going to want it? Well, once again, if we look at our confidence interval, it goes from 0.8 to 3.4, right? So what number would be bigger than it? Well, obviously, you could say 3.5, you could say 5, you could say 10, right? You could say 4. These are all relatively small numbers. So if you spent a year, right, on this diet, can we safely conclude you will lose less than 3.5 pounds? Yeah, because the entire confidence interval, right, any number within here, all those numbers that we wrote earlier are all below 3.5 pounds. All of them are below 4 pounds. All of them are below 5 pounds. So, because of that, we can safely conclude that you're going to lose less than 5 pounds, for instance. And if you go for a whole year, is anyone going to want that? No, of course not, right? So, is it practical? No. Because we could say, because we can safely conclude that you would lose less than 5 pounds, or 4 pounds, or 3.5 pounds, whatever you wanted, whatever you wanted to write. Good. All right, let's look at the next one. Problem number 2. Listed below are the gross amounts in millions of dollars earned from box office receipts from Harry Potter and the Half-Blood Prince. The movie opened on a Wednesday, and the amounts are in order for the first 14 days of the movie's release. So, use the sample values to construct a 99% confidence interval estimate of the population mean. All right, so it says mean, so we know we're going to do t-interval. They didn't give us statistics this time, so we're going to have to put this into our calculator. And anytime you put something into your calculator, remember you're going to stat edit. Type all of this into one list, right? Because we're just dealing with one list here. So after you do that, we're going to go to T interval. The input this time is going to be data, right? Because we were given data. So the list is L1. The frequency, well, how often does each of these values occur? One time, right? This 58 occurs one time. This 22 occurs one time. And you may be thinking, well, what about these 10s, right? Those occur twice. Yes, but if you typed in this 10 and this 10 into your list, this 10 occurs one time, and this 10 occurs one time, right? So just make it easy on yourself. Put everything in. Our frequency is just 1. And then we have our sea level. And our sea level for this is going to be 0.99. So when we plug it into our calculator, it's going to spit out 4.7 and 28.0. But what does this mean? What do these numbers mean? Right? It's fine that our calculator can spit out this, but we need to know what the heck it's talking about. So it's millions of dollars, right? So $4.7 million, comma, $28.0 million. Right? That's another way we could write it. Make it a little more exact. So we actually know what we're talking about. All right. Part B, identify at least one major problem with this data set. So there is a problem, and because there's a problem, we actually should not have done this problem to begin with. Since there is an issue, shouldn't have done this problem. So what's one thing that we forgot to do? Hopefully you noticed that we forgot to look at the requirements. Right? So we said either the population is normal or the sample size is bigger than or equal to 30, right? One of those two has to be true for us to be able to do T interval. Well, let's look at the easy one. Does our sample size have more than 30 values? No, right? It's just 14. So we definitely know that's not the case. So then the question is the population normal? Well, it didn't tell us, but let's actually think about this for a second. So if you have a movie premiere, is that going to be a normal distribution, right? If you talk about days where it's out, right? So this is the first day. It's the premiere. And then it's the closing day. If you actually graph this, are you going to see a normal distribution? No, hopefully you would notice, right? Because otherwise what that means is that when the movie first comes out, nobody wants to see it. And then like a couple weeks later, all of a sudden everybody wants to see that movie, right? And then nobody wants to see it toward closing date. That doesn't make any sense, right? So population isn't going to be normal. Actually, what would this be? Hopefully you saw this would be a right skewed, right? Everybody wants to go on the first weekend, and then it slowly dies down. So this is going to be a right skewed distribution. But, yeah, we can write that, right skewed. But, as we said, it is not normal. The sample size is not greater than or equal to 30, so we couldn't have done this problem, right? So that's a major problem with this data set. We shouldn't have done this to begin with. But it was good practice. All right, number 3. A clinical trial was conducted to test the effectiveness of the drug Zopiclone for treating insomnia in older subjects. Before the treatment with Zopiclone, 16 subjects had a mean wake time of 102.8 minutes. After treatment with Zopiclone, the 16 subjects had a mean wake time of 98.9 minutes with standard deviation of 42.3 minutes. Assume that 16 sample values appear to be from a normally distributed population and construct a 98% confidence interval estimate of the mean wake time for the population with Zopiclone treatment. All right, so Let's look at that requirements. Does it meet the requirement? Well, the sample size is not bigger than 30 this time, right? It's only 16. But it does tell us it's from a normally distributed population. So the population is normal. So we're all good. All right, since it says that confidence interval for the mean, we know we're going to do t-interval. Now, if it said confidence interval for the proportion, right, we would do 1 prop z interval. So getting those right in your head is going to be very helpful. Confidence interval for the mean, we're doing t-interval. So the input, we have statistics this time. So x bar. So this time, x bar, remember that's a mean wake time, so mean, but we have 2 means. So which one are we going to use it for? So hopefully you also saw that it's the mean wake time with the treatment. So we're going to have to use this number, right? This is after the treatment. So 98.9. Standard deviation is the one that goes with this mean, right? So that's another way you could tell. This standard deviation doesn't go with the 102 mean. It goes with the 98.9 mean. So that's another way we could tell that that was the mean that we needed to use. N is 16. And then the C level, they said 0.98. So when you see our calculator, it spits out 71.4 and 126.4. Right? And what's this going to be? What are the units? Hopefully you saw the units are minutes. Good. So, part B. What does this suggest about the mean wake time of 102.8 before treatment? Does the Zopiclone appear to be effective? So that's another, it's the same word, same question. Second question just might be a little easier to understand what I'm actually asking for. All right, so our confidence interval. So remember, we can't just look at this value. We can't just look at the value of our sample because we need to look at everybody, right? The whole population. We can't just use this. This might be an outlier. This might be a weird thing, right? We need to look at it for everybody, for the whole population. So that's why we got to use our confidence interval. So we see that the confidence interval goes from 71.4 to 126.4. And we see that the before wake time is right slab dab in the middle. So does it suggest that the Zopiclone appears to be effective? Well, let's think about this. What would it mean for it to be effective? Should you get lower numbers or higher numbers if Zopiclone is effective? Well, let's go back into the problem. What is Zopiclone trying to treat for? Insomnia, right? When you have insomnia, does that mean you have a higher wake time or a slower wake time? You're awake more often, right? You can't go to sleep. Which means that the Zopiclone hopefully is trying to decrease your wake time, right? So if it was effective, we would want this 102.8 to be bigger than our entire confidence interval, right? This would mean that this entire confidence interval, any number we choose in here, you are asleep more often, right? You are awake less often is another way we could say that. So this would mean that the Zopiclone is effective. That is not the case though, right? Ours is right slap dab in the middle. So you actually could have a mean of 120, right? That means it's actually keeping you awake more often, which that wouldn't be helpful, right? I mean, it could be less, right? It could be 100, but since it's just right in the middle, it doesn't really tell us anything. So does it appear to be effective? We can say no, it does not. Because the 102.8 is inside the confidence interval. So it can't really tell us anything. Seems like it doesn't have an effect. Yeah. All right. Last problem, and then we'll move on to sample size. So a common claim is that garlic, so an old wives' tale says that garlic lowers cholesterol levels. In a test of the effectiveness of garlic, 49 subjects were treated with doses of raw garlic, and their cholesterol levels were measured before and after. The changes, which is before minus after, in their LDL cholesterol have a mean of 0.4 and a standard deviation of 21.0. So let's construct a 95% confidence interval estimate of the mean net change after the garlic treatment. So let's look at the requirements. It's a confidence interval for a mean. So for the mean, right, we just need either the population to be normal or the sample size be greater than 30. And we see that we have a sample size of 49, so definitely bigger than 30. We're all good. All right, confidence interval for a mean. So we're going to be using t-interval. Our input, we have statistics, so we're going to use stats. X bar is going to be 0.4. SX is going to be 21.0, right? I'm just getting it from reading the problem, right? So if you don't know where these is going, just take a deep breath, go back, reread the problem. Most of this stuff is given to you. N is going to be 49. Sea level is going to be 0.95. So when we plug it all into our calculator, it should give us negative 5.6 to 6.4, right? And what's the units this time? So it says in milligrams per deciliter. You don't necessarily need to know what that means, but that would be what the units are in. All right. Part B. What is the confidence level suggest about the effectiveness of garlic? Does it actually reduce the LDL cholesterol? Well, first, let's go back and re-ask ourselves that same question. What would it mean for it to be effective? So it says the changes, it says before minus after. That's what we're doing. We're measuring. We're not measuring the actual levels. We're measuring the changes in the level. So before minus after. So if we have before minus after, right? And this is the change. So what could a number be? So I don't know anything about cholesterol, so I'm just going to use a random number. So 100. Again, if you're a medical person and that has nothing to do with cholesterol, then feel free to know more than I do and just laugh at this whole scenario. All right, so if you are trying to reduce cholesterol, then the after should be less. So let's choose a number less than that. Let's choose 80, right? So when we subtract, we get 20, which is a positive number. This is reducing cholesterol. If it raised the cholesterol, so let's say that you started with 100 and you actually had a higher cholesterol. This was raising cholesterol. What would we expect to see? So the after could be something like 120. When you subtract, you end up with negative 20, which is a negative number, right? So what we want to see, if it has an effect, it needs to be bigger than 0, right? Our whole confidence interval needs to be bigger than 0. And we see that the confidence interval goes from negative 5.6 to 6.4, right? 0 is right slap dab in the middle. So what does that tell us? Is it effective? Hopefully you remember from the last example that no, it is not effective because 0 is inside the confidence interval, right? Another thing you could say is no, because the mean change could be -1, right? Which that would mean an increase. So that's another thing you could say. No, the mean change could be mu equals -1, right? That's inside there. And that would mean that it's raising the cholesterol, as we said. So whatever you want to write, just make sure it makes sense. If you need to shoot me a text and say, hey, would this make sense? Or an email, I'm totally cool to look those over. Try to get you ready for the test and making sure you're understanding everything. Again, you don't have to write specifically everything I do. just as long as you understand it. Putting it in your own words is probably going to be a best way to do that. All right, so sample size for estimating the mean. That should be mean. All right, so here is the formula for it. So we have that critical value times sigma divided by E squared, where N is our sample size, sigma is the population standard deviation, E is your margin of error. We said that's your critical value, right? Critical value of alpha divided by 2, where alpha is 1 minus your confidence level. Again, I will give you this formula, but this is all I'm going to give you, right? Just this on the test. You need to make sure to know everything else, including this part. So when population standard deviation is not known, right? Either we can let it be S. What's S? So hopefully you remember S is the sample standard deviation. So a lot of times we're not going to know what the exact population is, but we could do a sample, find out what that standard deviation is, and then go from there. Or we could look at someone else's previous sample, right, and go from there. Or what we could do is we could do the maximum minus the minimum and divide by 4. So if you have a range of values, you do the biggest number minus the smallest number, divide by 4. And as always, we need to make sure to round up for all of these problems. All right. So problem 5. You want to estimate the mean amount of time internet users spend on Facebook each month. How many internet users must be surveyed in order to be 95% confident that your sample mean is within 15 minutes of the population? Based on the result from the prior survey, assume the standard deviation of the population of monthly time spent on Facebook is 210. So we use our formula. So critical value times sigma divided by E squared. So as always, we need to make sure to do critical value last. So population standard deviation is 210. E is 15. Notice this is 15 minutes, right? So last time it said something like, it could say something like 15 percentage points, right? And that's why we knew we need to change it to 0.15. But since this is just 15 minutes, right, we leave it like it is, just 15. All right, so now I got to find that critical value. All right, so we see that alpha is going to be 1 minus our confidence level. Confidence level is 0.95, so 1 minus 0.95 to get 0.05. But of course, we don't care about alpha. We care about alpha divided by 2. So if we divide everything by 2, we actually get 0.025. So we want to find the critical value of 0.025, which remember, it's inverse norm. So what you can do, right, 1 minus 0.025. This is going to be the top 2.5%, which means it's the bottom 97.5%. So 0.975, comma 0, comma 1. We end up with about 1.9599, blah, 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 right? Remember, you need to take this whole number, plug it back into our equation. So n equals that whole number, 599, blah, 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 times 210, divide by 15, squared. And you should end up with about 752.9, blah, 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 right? Since we always round up to the nearest person, it's going to be 753. So we need to talk to 753 internet users, at least. All right, let's do another one. And remember, if you want any partial credits, this is the way to go about it, right? Writing out all this on the test. Problem 6, research of selling prices for used 2-year-old Corvettes reveals that they have a standard deviation of $21.57. How many selling prices must you obtain in order to estimate the mean selling price of these cars? So it's talking about the mean, right? The mean selling price. So we know we're going to use our mean formula. We see that sigma this time is going to be 2157. That's our standard deviation. We see that E is 250. Right? We want to be within that amount, so that's going to be our margin of error. Then we got to figure out what our critical value is. So critical value, we use alpha is going to be 1 minus 0.98, which is 0.02. But we don't care about alpha. We care about alpha by 2, so divide everything by 2. So you want to figure out what is the critical value of 0.01. So that means we want the top 1%, which is the same as the bottom 99%. So inverse norm, 0.9901. And you end up with 2.32 blah, 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 blah. Make sure to put the entire value into your formula. So 2.32 blah, blah, blah times 2157 divided by 250. And when you square that giant number, you're going to end up with 402 point something. Since we always round up, that ends up with 403. So we need to look at 403 selling prices. If you're wondering how I'm doing this real quick, I already did this ahead of time. So that's why I'm going pretty fast on this. So feel free to take a pause. Make sure you actually can do this in your calculator. Make sure this is working for you. If you have any questions, you can always text me about it or email me about it. All right, last problem, and then we are done. Woo! So you want to estimate the mean SAT score of all college applicants. Possible SAT scores range from 600 to 2400. Use the estimated standard deviation to determine the sample size corresponding to 98% confidence interval or confidence level and a margin of error of 100 points. So once again, we are trying to estimate the mean, right? It's talking about determining a sample size. So now we know we're going to use our sample size formula for the mean. So critical value times sigma divided by E squared. So we can pretty easily see that the margin of error is 100. It literally tells us that, right? Sigma, though, that's a little harder. They don't give us a sigma. So if we go back, right? If we go back to what it said, it didn't give us a sigma. We can either use the sample standard deviation, but it didn't give us that either, right? It didn't give us any standard deviation. So what we can do is this formula. Taking the maximum value minus the minimum value and divide it by 4. So 2400 minus 600, because these are our values, right? The smallest you can have is 600, biggest you can have is 2400. And then divide it by 4. And so what we see is that we can use a sigma of about 450. All right, now using our critical value, trying to find that. So alpha is 1 minus 0.98, which is 0.02, but we don't care about that, so we want to divide it by 2. This is looking all very familiar, right? So you have your critical value of 0.01, which as we already saw was inverse norm of 0.9801, which was 2.32 blah 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 blah, right? Plugging that back into our equation. we see we get 2.32 blah, 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 times 450 divided by 100 squared. So when we do that, for n, we get 109 point bunch of stuff. And since we always round up, we know it's going to be 110. So we need to talk to or look at 110 college applicants. At least. That's the minimum number. All right. Like always, if you have any questions, feel free to text or email me.